Nikola Tesla knew that magnetism was the key to free energy.
Now, magnets is actually the key to our main electricity generating techniques, where there's a moving magnet through a inductor coils. So as the magnet moves and the magnetic fields move, it cuts through your inductor, the coils. So each coil, and that induces an electric field inside the inductor, and that's how electricity was generated.
Free energy. He also knew how to harness energy from the atmosphere. You could see that in the Tesla tower from
The Tesla tower wasn't used to harness energy from the atmosphere, or like he says, the ether. No, it was actually used as an wireless electricity transportation, basically to wirelessly admit electricity over distances. If you want to harness energy from the atmosphere, you basically do it with wind turbines or with the sun. Technically, it's from the atmosphere with the solar panels, not like this.
Tesla tower from the ether and provide the world with free energy. This is what the Eiffel Tower does as well. It was built to generate electricity for.
The Eiffel Tower wasn't built to create free energy. It was built in 1889 as an entrance arch of the World Fair that was held in Paris. That was held as the 100th anniversary of the French Revolution. The Eiffel Tower was built by the company Gustave Eiffel Engineering, where you can see where the Eiffel Tower got its name from.
Electricity for everyone for free. This is why they got rid of Tesla. Now,
Nikola Tesla died in January 7th, 1943, in the room 3327, the New York Hotel. He died of a blood clot that went through his heart at the age of 86.
Now you can do this at home yourself and generate free power for yourself.
That's definitely not the way you're gonna generate free power for yourself at home. That is an example of electrical induction through magnetism. Now, any conductor that has an electrical field running through it, or stream, it inducts or creates its own electric field around it. As an example of how that circuit they built on the video works, here I have a Samsung watch. Like you all know, there's no contact points or anything at the back. There's only a coil running through here. In the back where you can see it, they cover it up obviously. And then you have this puck you put it on. This is with wireless charging. Now there's also a coil inside here. Now from there's an electrical field created, put through this coil. It creates its own magnetic field around it. So that's fluctuating. So when you put the watch on it, it transfers that electric or that magnetic field, creates an electric field inside the coil of the watch, and there you see it started charging. It's not magic, it's not free energy, it's just science, and you actually do need the power to be able to do that. And you can build a circuit like that at home, but to be able to get a light like that to light up, you also have to put a coil underneath. That's what is hiding behind that green, I think it looks like felt over a cardboard or something like that, but that's underneath it. If you do something like this, just make sure you use a wire with a actual resistance or a insulation, because if I touch it arcs, it wouldn't work. And if you want to see examples of how electricity is created through a winding, you can, for instance, take a toilet roll, wind a wire around it, take a multimeter, put it to each side, and take one of your strongest magnets you can get and move it through the toilet roll on the inside. And that moving magnetic field that has that magnetic lines cutting through the inductor will create an electric field inside the conductor, and that you would see on the multimeter or the voltmeter. That also, if you have a permanent magnet motor in certain industries, like in the compressor industry where I work, we have it there. If you take that leads where you give power to the motor and measure the voltage on it, and somebody turns the motor, you will also see the effect of it.